All right, so we can go ahead and get started as people may be trickling in here, but we'd like to kick it off with just a little bit of introduction. So today, Dan, Marcq, and I will be talking about risk reduction for connected devices, and it comes in kind of all parts of the device creation, and we'll get into some of those details. But first, I'd like to take a minute to introduce ourselves. So my name is Brian O'Connor. I'm the software engineering manager at Bresslergroup. So that's anything with firmware, API services, any cloud services, and mobile applications as well. And so everything in the software world that's needed to run an Internet of Things device, as well as software that runs on medical devices.
Hi, my name is Dan Marcq. I'm the electrical engineering manager and program manager at Bresslergroup. I run the EE department and also help with technical work in the EE fields and also electromechanical devices.
So today, before we get into some of the risk reduction takeaways that Dan and I have to share based on some of our experiences, we'd like to give you a little bit of information and background about Bresslergroup, as many of you may be familiar with some of our services, but maybe not the entire offering that we have in-house. And then we'll get into the four main topics, which are considering connectivity, part selection, prioritizing development testing, architecting, provisioning early, and then planning for production testing, all part of reducing the risk of your product and your project's timeline. So a little bit about Bresslergroup. So we are an insight-driven innovation lab. One thing to note here is that Bresslergroup was categorized by the state of Pennsylvania as an essential business. So we are operating at full capacity. We have distributed our teams and labs to where those individuals are able to work remotely. And we do have access to our shop in our office. So we are operating. We're still solving these complex development challenges. And we're excited to keep doing that through this pandemic and shutdowns. So Bresslergroup is, we like to say, comprised of 7 disciplines under a single roof. And our offerings range all the way from future planning, so that's like 5 to 10 years out with design strategy, all the way through to the engineering side of the house. And so we're comprised of about 70 to 75 individuals that fall within engineering and design services. We do user research, which is typically 80% of their work is in the medical device space, whereas across the rest of the company, we're about 50-50. We offer interaction design services, industrial design services, and then the engineering. So it's really where the creativity meets the rigor, all under a single roof. And as I mentioned, so we're over 70 design and engineering professionals. We've been operating for going on 50 years now. And we benchmark ourselves on a couple metrics, as you see here. So number 1 is design awards, and we've won over 100 design awards. And number 2 is the number of patents that we have been named in. And so we've been named on over 230 patents, most of which are utility patents. And lastly, before Dan and I get into some of the nitty-gritty about risk reduction, we just wanted to showcase a few products and projects we've worked on in the past. All of these devices we've had a hand in developing, so you can see that there's a wider array of devices, from both consumer electronics to medical devices, devices that operate with or without software. As you can see, we have extensive experience here in product development. And so we'd like to talk through some of the experiences we've had in reducing risk through the project timeline. So I'll turn it over to Dan to kick that off.
All right, so I'll get us kicked off on the subject. What we want to talk about again today is risk mitigation and looking at technical risks. So first, to start us off, we want to talk about products fail when they fail to launch on time or hit key customer insights. Oftentimes, these two things can be tied together. When you become late, you start to fall behind, and when you fall behind, you can't focus on the work you're trying to provide to your customer. A lot of this can be setbacks from under-prioritizing technical risks. If we look at it from a number standpoint, we have 40 to 60% of all projects fail to be completed on time. So imagine that you're a small startup. Time to market is really important to you for success. Being late to the market means that you're going to lose that market share. It also allows competitors to move in. If we look at metrics again, about 9 to 12 months late corresponds to about 50% loss in potential revenues for the product. That can be detrimental to your product and your business. So of course, releasing on time and planning ahead for these types of events is important. So the question really comes down to is how do we reduce technical risk and provide the time required by core development teams to build customer-driven features? The first section I want to stop in is the connectivity part. So we're going to go through part selection. So part selection is the first part of any project. We know that when we start dreaming up our product, we have to start putting it together. For a complex device, it could be a semblance of a lot of different parts. For this section, we're going to focus in on the RF parts in this case, pre-certified versus chip down. So again, this is your first phase. This is your first opportunity to kind of define the path. The better we do a job here, the more successful we will be in the future. And again, pre-certified RF modules are a good design requirement, especially for people that don't have RF experience and are trying to get something off the ground and ready to go fast. So again, at a high level, RF module, it's a subassembly that's capable of sending and receiving RF energy. I know that's kind of a summary of it, but again, you have different forms of this. You have Wi-Fi, you have Bluetooth, it's whatever fits the actual application that you're looking to do. So pre-certified modules come as a module. They are actually already tested. What that means is that someone else has already gone through, created a little custom PCB. They've already put all the parts on there. They've already done the RF antenna tuning. They've already matched all the components. They've already fixed the pipelines for you. They've already shielded the component. So they've actually done all of that design work, which is actually significant. The development time that actually making around chip down design compared to pre-certified is a big delta, and that's because you have to actually design in those RF components. So when you get pre-certified, you're actually buying someone else's design work that they spent on that. The other aspect too is it has an FCC ID. That's really important because the FCC ID is implied that they've already gone through the certification process, and that's for that's intentional radiation that they've already gone through. There's still unintentional that you need to go through, which I can cover later, but at this point right now, you're getting ready to go to the FCC. You don't want to go through an entire FCC vet. If you use a pre-certified part, you're actually going through a subset of the FCC testing. So your path to getting that certification completed for your product is quicker. It's a really good fit in that application space. And since it already has the FCC ID, you're actually cutting out a lot of paperwork time. That can lag 4 to 6 weeks for you to get approved for an FCC ID. The cons of this approach, though, come with its cost. It does have a higher unit cost. That comes from the aspects that you're kind of paying in advance for your certification. You're paying in advance for the development. You're paying for someone else to do all the RF work for you in that case. The other con is antenna design flexibility. It's an important note here because you can't really adjust the antenna without adjusting the design. And if you change the design intent of that pre-certified module, you lose all the benefits I just previously stated. So you could lose the pre-certification of it. You might have to go through an entire test again. So in this particular application space, you want to stick with the app notes and the approved antennas. Typically, there's usually 1 to 2 antennas that they have approved through their FCC testing prior. And again, the big one here is fastest to market. So if you're trying to hit timelines, you can typically get this done in about 2 board spins as compared to 3 with your chip down designs. So reviewing a chip down designs are still a good fit. They typically require someone that's got RF experience to be successful. Again, you have to go through and do the tuning. You have to do the matching. You also have to go through the iterations and make sure they're going to pass the FCC emissions. The big benefit here is actually you can get reduced costs. And now I say you can get reduced costs because there is a chance you may overcomplicate your PCBA and actually make it more expensive. Again, that ties back to having an experienced RF designer working on that chip for you. The other benefit that you get is that long-term for a production standpoint, you have more control over your process, which allows you to pick discrete components. You're not tied to a particular vendor. So there are like opportunities for you to actually adjust your pipelines down the road to continue to save costs. From the negative standpoint, it doesn't include the FCC testing, which means you have to go through the entire subset of FCC testing. That does take much longer. And as part of that, you also have to go through the paperwork process to get the ID. So not only do you have to schedule, get into a test house, pass the test, but you also have to go get that FCC ID. So the con on that is also time to market because of that impact. So if you're trying to go quick and you don't have the RF experience, the chip down design is probably not the best approach. I would say the pre-certified fits that need. On the first scenario I just want to capture a couple of notes on here as we go through. If you look in the upper left corner, we have some of the criteria to the scenario. In here, I'm assuming that your annual volumes are less than 15K. Your product launch date is very critical, and your development costs are more important than your cost of goods, right? So the reason why I have 15K there is that's really right around the trade-off. You can go and look at a lot of different white papers. It's somewhere between 15 and 25K, depending on like the cost of goods for your product, where you get the benefit of the chip down design. But again, you have to kind of look at it from what it costs to actually do an entire development cycle. So it may not be even a fit if you're somewhere between the 15 and 20K marks. You might still want to look at pre-certified. If you look at the upper portion, we have pre-certified module. That typically will take 2 design spins to go through and get you to your production ramp up. These are simplified diagrams, of course, so I'm trying to show them in smaller diagrams. And this is assuming that you have a medium to like low complexity design. Now, the lower one is the chip down design. What we're trying to show there is that there's a chance that you might have to go back and do a design iteration 3. That's assuming that you still can't get through the certification. FCC certification for new antenna designs and new emitters is actually very challenging. What we see on our experience so far is like 6 to 12 months longer for those to launch. So you can see already it impacts your launch timing. So sticking with the pre-certified is probably the best in those cases, assuming that you have low volume. So recapping everything, just kind of suggestions here. The pre-certified module is a really good fit for time to market. If you're looking to go quick, stick with pre-certified. Development costs are tight. Pre-certified will get you that 2 spins as opposed to the 3 spins. The annual volumes, 15K or less, think somewhere between 15K and 20K. Above 20K, you can start thinking about maybe going chip down. The other one too, it's important, is that supply chain is not your core competency. It's challenging to source a bunch of different components. So when you do a chip down, you take on that responsibility of maintaining the alternate vendor list. That can be a big challenge for a small business. So it's probably better to have the one component to source as opposed to having many components. So for the chip down design, they're a better fit for RF engineers. So you have RF experience internally or externally if you have a consultant that can provide those services for you. Annual volumes are greater than 15K. So again, 15 to 20K is that cutoff line there. And then the other one is your cost of goods outweigh. So if you have a very high volume product, it's probably best to think about this because the impact annually can be significant if you're paying $5, $6 more for a particular part. And then the other one too is if you're trying to hit time to market and you also have long-term cost of goods, so imagine you're a high volume supplier or you have the potential to be, but you also want to get in that market quick. You can think about phasing the approach. So you can run an initial launch that is pre-certified module and then have a close follower second revision. Think of it as like a first and second generation product where really the RF component is the part you're changing the most. And you're doing that because you want to capture both benefits here, right? So again, development cost is a lower impact to you, so that's why you stayed in 2 programs. The next subject we want to cover is the prioritized development testing. So the main takeaway in here is don't wait until it's too late to test. Oftentimes we put off testing until later in the program. Testing does take time. Testing is always like a block of time at the end of a phase. So if you have multiple iterations and you have 2 weeks at the very end, it always feels like you're just adding time. It's slowing down the project. You're not moving enough. You're not moving fast enough. You're not getting enough features done. The real implication of skipping over testing in earlier phases is that instead of it being a learning opportunity, it's now a risk to your program overall. So I think we've all said it before, we've all heard it, we're making minor changes, what could go wrong? The module is already pre-certified, we don't need to be concerned. Like I captured before, you actually still need to go through FCC testing on pre-certified. You have to go through the unintentional emissions. So again, if you minimize what that risk is to you and you wait till the last minute to do that test and you get bad news, it moves it from a learning experience to an actual risk to the program. So the big one too is to identify the correct test to prioritize. In most cases, what we start to focus on is what we're selling to a customer. You're making a new connected device. That device needs to collect some data and make sure it's getting data collected, and that customer is getting that benefit from that data collection activity. Now, we're always looking to test that, but that's something you can test kind of in cycles. Imagine that's being broken up in an agile method, and you have two teams working together, a software and a testing team. But the things we overlook is the environmental, the FCC, or any certifications we need to sell in different markets. Imagine you're going worldwide. What we do when we put those off is we're actually pushing the hardware up against the wall. And we don't want to do that because the hardware changes are going to cost you 4 to 6 weeks, right? And then you have to schedule for a test. Before you know it, you're already out 3 months. So some of the questions I think that kind of inspire the thought here is, what is the impact of not passing a test? You should think about that. If it's going to include a hardware change, it's probably something that should be prioritized. Do we have time remaining? That's another important one, is you want to look at what you allocated for the entire project. You don't want to just wait until the very last minute to try to pull that off. It's better to try to pull it in so that way you have more time behind it to make the iteration. Can we afford another costly hardware iteration? That's another great question. Like I showed on the previous slides, if you go to the third iteration, you're already pushing out your timelines. You're already paying for engineers to continue to do work. And at this point, you're not doing work focused on customer work. You're doing work that's focused on just recovery, because instead of learning from the problem, we're actually responding to the problem. So on this slide here, what I want to talk about is pre-screening testing. This is something we do very often at Bresslergroup, and it's had wide success for us on many programs, and it's very important, is that you want to try to pull in your critical tests early and often. Again, kind of reflecting on the last slide, think about environment. Think about FCC, think about UL, anything you can kind of pull in and get some of the prelim testing done will benefit you later. So on the top of the slide, we have including pre-screen testing, and on the bottom, we have not including pre-screen testing. So what we're trying to show there is that when you pull testing into a planned iteration, so design iteration 1 is planned, right? Call it the major iteration. This is when the product comes out and looks and feels like what you're trying to shoot for. When you pull that pre-screen testing into that phase, you already have another phase plan behind it. Anything you pull in, instead of it being a failure or viewed as a failed test, is now a learning opportunity. It's actually something that you can gear up and actually respond to in a planned iteration. And when we're responding in a planned iteration, you're not spending unspent money, right? Because again, you already had the money planned. So it's important that you want to have the learnings in planned work, not planned work. The bottom one's going over not including pre-screen testing. And this can happen very often. The longer you put off critical tests, the more likely you are to run into unplanned iterations. And again, you don't want to wait till the last minute. In this example, talk about FCC. You're trying to go through, you think the FCC is going to go quickly. Instead, what ends up happening is you have minor emissions issues. Next thing you know, you have to add a board change, you're adding a cap, and now it's a whole iteration, right? And it's a simple iteration, but still you have to get the boards. And that takes 3 to 4 weeks already. And then you have to schedule to get back on site. That takes another 2 weeks. So again, already you stacked up 2 months worth of dead time on the end of a program. And that's not a good place to be if you're trying to launch quickly, especially with the way that IoT devices work today. Everything's connected. Everyone's trying to get to market quickly. As soon as you start having delays, someone else jumps in and takes that market share. So the takeaway from this area is always try to include testing rounds throughout development cycles. Encourage your teams to be testing, inspire them to test early and often. When you push testing off or when you minimize the test, all you're doing is pushing risk into the back, right? It feels like you're moving faster though at the same time. So like we didn't have to wait for the test, we're already moving on to the next iteration, but you cut out all that learning experience, all that gets pushed to the back, that becomes a risk. And now when you actually have failures, you're going into unplanned work. So the other thing I would suggest too is make sure you track high risk design requirements. This is really important because you want to make sure you track those and tie them back to possible implications they may have. The other note too is front load learnings. Like I had said, it's better to pull something in because then it's a learning opportunity as opposed to a recovery operation. And then include scheduling impacts for testing and facility usage. We often overlook that. It's important to assume, especially in today's environment, that you may be looking at 2 to 4 weeks for you to get that test time. So you want to make sure you call in advance to try to pull your lead times in. Again, it just kind of helps to make sure you're planning ahead.
So when it comes to architecting devices, and specifically connected devices. We want to make sure that we're planning out that connectivity early, and it's not just the provisioning process that happens when the consumer receives the device and they're connecting it to their home Wi-Fi. So there are several steps that happen kind of further up in the stream that need to make sure that they're architected. And a lot of that has to do with the factory. So how are things being flashed? How are you verifying that connectivity happens at the factory? And then also, how is the connectivity happening in the consumer's house? So to reduce risk further out in the project, we want to make sure that we're architecting that early. And when it comes to connectivity and Internet of Things devices, we have a bunch of different options. Some of the more popular ones are Wi-Fi, Bluetooth, LoRa, cellular. So you need to ask yourself, what are those use cases? How is your device actually going to be connected to the internet or a network? From there, you need to also understand what the security implications of that connectivity are. If you look at the device from the device's perspective, how are you verifying that the services and the server that you're communicating with are indeed the correct server? And so how are we avoiding the man-in-the-middle attack? How are we avoiding some of the other security implications that come with connected devices? And then lastly, if you look at the server, how do you verify that the device that is connecting can actually be, is indeed a true device that you're expecting, and it's not a malicious device that's trying to connect to your network? So some options for both of those are both CA certificates flashed to the device, ensuring that the server is indeed who they say they are. And then likewise, on the flip side, you also have CA certificates, and you want to make sure that devices have X509 certificates installed, as well as private keys. So once you identify your connectivity and what that looks like, we need to identify what, where, and how those certificates are flashed onto the device. So in terms of what those certificates are, you can see an example of a certificate over here on the right. But you need to determine if you need to flash in private keys, if you need to flash CA certificates, and what does that look like? And part of that will feed into some component selection, as you need to identify where those certificates are housed on the device. It could be flashed to EEPROM, or it could be residing on a component like the ECC 608 chip. So once you understand how those certificates are flashed or received and stored on the device, you can then begin to determine how that will happen. That can come in a number of forms, and so we'll get into a couple different options from what we've seen in the past. So what you're looking at here, and we'll start in the top right, this is a diagram of what's called just-in-time provisioning or just-in-time registration. It's one of the many options to where you have certificates flashed to the device, and then you get official certificates that are retrieved once the device establishes a connection to your true network. So this is great for environments to where you need to operate in an offline fashion, because you can flash the either one or a handful of certificates to devices to ensure that they will identify themselves once they establish that connection. And then along the bottom, what we're looking at here is something called the certificate vending machine. This is a pattern that we've actually used pretty recently for a device, to where certificates are fetched through a known entity. So in our case, it's an application that has a user that is authenticated and has privileges to receive and generate certificates. Those are then downloaded and flashed to the device in the factory. So in order to get to kind of one of these architectures, you need to understand what tools are available at the factory. So that's things like your connectivity and bandwidth, and what devices are you actually using to flash certificates onto your device. That could be a laptop, it could be a mobile phone, it could be something else, but that'll help understand what's actually feasible. And then make sure you evaluate what your provisioning process is, whether that's just the just-in-time registration, just-in-time provisioning. You may need to install a PKI server to handle some certificate fetching while you're essentially offline from the rest of the internet. We see this is particularly prevalent in places like China, to where sometimes you don't have full connectivity back to the United States or to the world. And then sometimes the network reliability is not 100%, and you need to be able to operate in that offline condition. So a couple key takeaways to reducing risk through the project timeline as we jump to the next slide. So number one, make sure that you're designing the provisioning process with security in mind. You will need certificates to ensure a secure connection between your IoT devices and the cloud. So make sure that you keep that in mind as you're architecting the process, and that it doesn't just happen at a consumer's house or a place of business in the United States or Europe. You need to be architecting this in a way that'll work in wherever you're doing your manufacturing. So number two, evaluate the factory capabilities. So as I mentioned, you may need to work within their constraints. So identify those early, so that way you're not kicking that can down the road and waiting until your production line is set up to solve those problems. Be prepared to take the process offline. So what we found is that a lot of factories do experience outages, whether that's in the United States or elsewhere. So make sure that you are able to either react to that issue arising, or if you need to be prepared for that from the beginning. And then lastly, identify provisioning processes for all steps in the product lifecycle during design and architecting. This has major implications on both your software architecture as well as your network architecture. So make sure that you're identifying that early to reduce that risk from the long term. And before we jump into the last one, I just want to say one other thing. We do have a chat as well as a Q&A section at the bottom of this Zoom, so please feel free to direct any questions there. And Dan and I will be fielding those towards the end of the conversation.
Okay. So we've taken on the journey so far. We started with product definition. We worked our way through the development test. We've talked through provisioning. The next step is that you're getting ready to launch your product, and now we're going to start talking about planning for production tests. So the main takeaway is that quality assurance doesn't stop as soon as the product is launched. If anything, it gets more complex. Now you have to manage the actual hardware you have coming in. You have to make sure that you're vetting it, because you'll probably have contract manufacturers sending you goods. You may not have the same assembly houses too. So that means you may have a PCBA fab house that's sending you a custom board, and then you're assembling that into a custom unit, which means that you have a bunch of goods coming from multiple vendors at this point. So there's quite a few production testing fixtures that you can integrate into your manufacturing plan, which allow you to try to catch things earlier into that production cycle. Because again, the point of this is that the earlier you find a rework issue, the cheaper it is to fix. So in a rush to get to the production launch, we often overlook this. It's important that you start thinking about it early in their definition phases. Again, you look at it as a volume problem. Like the lower your volumes are, the less you need on the manufacturing line. The higher your volumes are, the more you need on that manufacturing line. So again, I'll go through three of them right now. There's three tests I want to talk about. It's in-circuit tests, which is really focused on your PCBAs. Functional circuit tests, which is sub-assemblies. It's also a good test for off-the-shelf component manufacturers. So you're not bringing in custom PCBA boards, but you're bringing off something that's off the shelf and you're putting it into your device. And then we have final tests, which is going to be on the final assembly. And if we look at the graphic on the right, you can kind of see how it walks through. And at the very top, I'm assuming in this case you have a custom PCBA. Again, if you don't, you bypass that first two lines. So you create your PCBA that's at your fab house that would go through an in-circuit test. The intent there is to try to identify failures when it's on site with that vendor or that CM, and then have that CM fix it before it actually gets further down the pipeline for you. So now let's look at it. It passed through the in-circuit tests. Now it's going down to complete sub-assemblies. What you're doing here is you're actually building out your product. Again, if you reflect on the initial slides we had, assuming like medium to high complexity device here, you would end up having a lot of components internally, mini sub-assemblies that have to be tested. They may have impacts. There may be sensor assemblies inside there. What you want to do is run them through a functional circuit test. Now, there's different ways for a functional circuit test to work, which I'll cover on the next slide, but it could be just a pure mechanical test, which will just make it a functional test, which I can talk through. Assuming that you get through the functional circuit test, you move down to complete and final assemblies. This is where your finished goods get polished. This is where they get cleaned up. And then you go to final test. Now, final test is responsibilities to go through some of the other activities we've already mentioned, like provisioning. They're going to go through serialized units. They're going to make sure they put down custom firmware on the units. They're going to go through and calibrate units for you. Final test fixtures do provide a lot of value. They do require a lot of support, though. So a final test fixture is definitely the most expensive of all the fixtures that you can have in a line. They're very fit for like high volume lines in my experience, typically something that's measured over like 100K or more. Most lower volume ones you can get through with like a slightly upgraded functional circuit test. The last state is the final product. So after you get through your final test, your final product will come out. This is your packaged goods. This is what you're sending off to your end user. This is what they receive on the back end. And again, it's already gone through a whole vetting process. So you know that what you put in that box is going to work when it comes out of the box. And that's really the takeaway, because you don't want to send something to somebody if it's not going to work. So going into each one of them a little bit more, we have in-circuit test on the left. Again, that's abbreviated down to ICT as a common term. It's also known as bed of nails. In many cases, if you're working with a contract manufacturer, they may send like a photo of a device to you saying, we got to build this fixture. And it will look like a giant clamshell with a bunch of nails in it. And that's why they call it bed of nails. In many cases, it's a PCBA level test. You can make them pretty complex. They can do firmware. They can do some firmware testing as well. In many cases, I've seen them be better off being specialized to just finding hardware defects and then use your functional circuit test as a backup to it. The PCA test point coverage is really key here. And you don't want to put test points everywhere. Test points can have impacts on RF circuits and other elements of your design. Maybe your sensors are sensitive to them as well. So again, you want to work around, you want to get as many as you can. I would say the goal should always be get them like 90% or more coverage if you can, because you don't want to impact your circuits, but you also want to make sure that your ICT has a lot of coverage so you can find any failures. And again, the main thing is they're going to go through the component level and verify if anything's been misplaced. Imagine that you're building a product, you have a contract manufacturer that's offshore, they're overseas in China, and they're sending goods back to you. You don't know if there's anything wrong with them before they go out the door, so without that there, you're basically shipping blind. So you may be receiving goods in the stateside, and you have all these products that don't work all of a sudden. It was because of a one part thing that was off. Again, catching it at the CM side is a good thing, because then they have the opportunity to see the issue, correct the issue, retest it, and then send it back to you. So again, it's a good product to have. I have seen them be pretty expensive. It doesn't matter where you build them, whether it be domestic or international. They do tend to carry a pretty high cost as far as the manufacture process is concerned. So kind of keep that in mind. You want to make sure you kind of fit the best solution to your product line. It depends on how much money you have as far as capital here. Functional circuit tests, those are typically the cheapest to implement. You see them on low volume products. They tend to be built up out of maybe some of the mechanical components that you have in your design. The intention on a larger product is usually subassembly. So as you imagine your manufacturing line, you have subassemblies getting created and then they get combined into the finished good. You want to make sure each one of the subassemblies work. Because what ends up happening is if you don't test those beforehand, you end up having a large device that's already assembled with a failure. Now the question is, how do you find the failure? So again, the functional circuit test is supposed to help you find that failure before it gets more complex for you. These do require firmware in my experience, especially if they're testing anything that requires like a sensor or a circuit board in there. So it's always best to make sure you plan in like a production firmware. You can put it into your customer firmware, but I usually say that you should probably have like a production version and a customer version. That way you can kind of have your own liberties with how they work, and you don't interrupt anything that might be in your client-facing work. And then the other one too is you want to focus in on high-risk functions only, especially if you're working against a budget on the capital side. But these are the lowest investment to get into them. Typically, they need like a PC to accommodate them, and then, like I said, some firmware, and then the mechanical parts. So when you look at it, these are something that's like you can reach and you can grab onto that helps you manufacture it with quality. Final test. This is the final assembled unit. It does require firmware. It does require a lot of software. Depends on what you do on your lines. These can be automated. They can get really complex. You know, imagine like you're at an automotive company. I mean, these would all be automated fixtures at the end of the day. My experience with high volume manufacturing is that they were all automated on my lines. We were always 150 to 200,000 units. The automation was great. It had all this tracking, but it was also very challenging and made the test cells very expensive to maintain. The good news about them is that they do all that tracking for you. They're very great at doing the serialization, getting the customer configs on there, and getting the labels printed. So there's a lot of things you can do in this final station to simplify your production line at the end. And they also make sure that they do some basic function tests to be sure that once everything comes together, it's not going to fall apart when it comes out of the box, which is the key here, because you don't want to send something to your customer that's not going to work.
Yeah, and one thing just to add a little bit of color to that final test, it's great to reuse any sort of unit tests that you've written throughout the process. So if you have some of those tests that you can bundle up as part of the firmware, you can reuse those as part of this process. So just another reason that test-driven development has kind of taken on a lot of advocates recently. So we also believe in writing test cases early and often, because we do see the value in both regression testing as well as kind of the factory testing and the final testing.
So kind of going back and looking at the in-circuit test and where it is in the production cycle again, it's your first line of defense. It's right up front. It's going to be testing the PCBAs, the custom ones you're making. It stops you from sending bad goods into the rest of your pipeline, which impacts your final test and everything else you're trying to run. And again, it's the lowest rework costs, because again, if you catch it right before it ships, you're not incurring all the shipping to move it around. The main takeaway on it too is that it is going to verify part tolerances, especially if you have a lot of critical components that have to be within tolerance. There's ways to design these fixtures and do all that for you. And then again, capital goods, they do cost significant money to build out these bedded nail devices. So the next one is the functional circuit test. Functional circuit tests can also be just a mechanical test, like I said earlier. It doesn't have to have the circuit part of it. What the intent here is that you want to test your sub-assemblies as you're building up a device. My prior experience, you have multiple sub-assemblies on a line. Each one of them always ends on a functional test. The intent there is just to run them through to make sure that they've been assembled. As you can imagine, with things getting more complex, especially with mechanicals meshing with electrical components, it's always good to have that pit stop to make sure that it's still going well before you finish up. And again, it's all about labor rates. You want to keep your labor rates as low as you can. And then in many cases, if you have a low volume product line, this is probably the fit for your final test. And then final tests, from my experience with these, they're very complex. They do a lot of work. They're great tools to have on your lines, especially if you have high volume products. If you're a low volume product, stick with the functional circuit test or simplified final test. They can include automation if you need that. They do serialization. They can do all the labeling and all that, the scanning. They can do all the verification. They can check LEDs and all that stuff too if you need them to. You can design it as much as you like. In many cases, you want to just focus in on the big hitters and then just do functional circuit tests to catch the earlier outliers up front. It is the final test. So again, if you do find issues in the final test, it tends to be the most expensive to fix those issues, which again just pushes back the importance on the prior to the ICT and the FCT. So the main takeaway here is that you want to define a control plan for your manufacturing process early and often, and revisit it as you develop, right? Because as we learn through our development cycles, you'll continue to learn. So even if you have a draft of something like that early in the product cycle, you at least know you have visibility that you're starting the process, and as you keep iterating, you can keep adding to that document. You can treat them kind of like product requirements documents in that case, something that also grows throughout development. The other takeaway too is low complexity, low volume products. You can stick with FCTs as your control, quality control. They're also very good fits if you basically are just making a PCBA and some mechanicals on site. It might just be a good fit just for that because you're not shipping things in multiple locations. For higher complexity devices, you're probably going to want, in high volume, high complexity devices, you're going to want to try to stick to all three, especially if you have custom PCBAs. You want to make sure they run through an ICT before they go in. My experience with these, it does get expensive, obviously, buying a lot of ICTs and FCTs to support your product line, but the fact that you can just run it and it just keeps running itself and you're not going in and interrupting it, and you're having lower dropouts, and when you're actually building up units, you're actually hitting the metrics you need to hit, it actually pays off for itself, because again, you don't want to waste your manufacturing labor. And then high complexity, low volume products, you may want to look at doing an ICT and an FCT on that as a fit. You can also think about combining the two. I've seen those creative solutions as well. Like I said, sometimes it's better not to overcomplicate an ICT just to keep the cost on it down, but you can add more to it. I have done that before myself, but combine the two of them. And remember, the big takeaway is manufacturing control plans, you spend a lot of time on them. They can be pretty expensive with the thought process and the design work that goes into them, but also the impact on unsatisfied customers is also going to cost you a lot more. So that brings us down to the end of the webinar today. We do have a Q&A section like Brian was just mentioning a minute ago, so I'll leave it open so you guys can continue to ask questions. What I'll also do here too is just kind of reflect on, we also have other webinars coming up as part of our spring series. Next week we have the digital physical workflows. We also have the recording from last week, which was innovating for 2030. I'd also like to take a minute to just reflect that we also have newsletters available. If there's certain content you guys would like to sign up, please subscribe. We're always generating new content as we're like thought leaders in these market areas, and something that we take a lot of like time with, and we really appreciate people reading. And then the last one I'll mention is that we do have the option for virtual coffee sessions. This is setting up opportunities for us to actually meet outside of the webinar. We can continue to go through detailed questions with you. The way this will work is you can sign up for time slots. Again, you can follow the link provided here, but I did want to call it out again.
We do have a few questions already in the chat. So, I mean, I'll start off with one from Todd, which is asking, where do you get certificates and how do you manage them? So that's a great question. Anybody can generate a certificate. You can download a few tools to just generate those certificates. But really, I think the power is in the second one. How do you actually manage them? So a lot of cloud services now offer native services and tools to allow you to manage those certificates, manage the end-to-end supply chain of those. So that way, if you're working with a third-party vendor that's flashing certificates to devices, you can allow them or you can give them access to certain certificates, and those can generate additional certificates. So, for example, on Amazon Web Services, that service is called KMS, or Key Management Service. And it allows you to get full control over where all of your keys are, how they're stored, how they're managed, and what they have access to. And so we like to rely on those services because they're robust, and they're great key stores that allow you to do a lot of that management and have that governance in place, rather than rolling your own sort of key management service. And then in terms of things like IoT devices, I'll talk about another AWS service here in a second, but typically your IoT device is going to have like an X509 certificate, those CA certificates, and a private key. And so with some cloud services like Amazon or Azure or Google, you can generate those and store them there in that native service. So on AWS, the service is called IoT Core. You can generate a certificate as well as a policy, and you attach those two together along to a device that's registered. And that will generate the private key and the X509 cert that you can flash in the factory to the device. So depending on exactly how you want to set up your provisioning process, that example I just gave is in like a bulk provisioning process or a certificate vending machine process. If you want to do just-in-time provisioning or registration, then you can just generate the CA certs that you flash to the device in the factory, and then those the X509 and the private key are generated on that first connection. It's a little bit more infrastructure that you have to manage, and you have to write some software to be able to orchestrate and facilitate that connection. But you have plenty of options there, and so happy to talk more about those if anybody signs up for a virtual coffee hour. So another question.
And I'll answer another question that just came in too. So I got another one that's in from Todd as well. And yeah, and Todd, I mean, I do agree with the price breakdown and the higher need for a volume. Like I was saying before, like 15 to 25K, but it can go north of that. It all depends really on what the initiative is internally. My experience has always been anything that was like above 50K at the last company I was at. We always did a chip down design on it. That was mainly because the cost of goods were so critically controlled. Mainly because inventory numbers were controlled so highly. In most cases, I mean, the takeaway I'm trying to have here is that I think pre-certified is a good fit in most opportunities, especially when you're trying to move fast. The chip down design does have its own complications. And I also was struggling to try to see where you can get the cost benefit depending on what happens with the layout and other implications you may have. It also goes down to sourcing needs, getting the shielding and stuff. So yes, I do agree with the comment. Prices have changed in the past like 3 years, and I think that pre-certified remains pretty strong going forward.
The next question is, in the healthcare industry, which wireless technologies are you seeing strongest growth in utilization and why? So I'll give a little bit of color to kind of what I'm seeing, and then I'll let Dan also chime in here. In terms of the wireless technologies, a lot of it depends on the type of device that we're looking at. Bresslergroup's been involved in a lot of analyzers recently, and an analyzer is a device that will take something like a blood sample, pipe it through a microfluidics chip, and analyze it, whether it be the photon emission with a reagent or some other method. And what we're seeing there is typically those devices want to integrate with a LIS, or a laboratory information system. And the way that you typically do that is over like an HTTP connection that's also leveraging a protocol called HL7 or FHIR. That communication, because it is over HTTP, we typically see either like a Cat6 connection, or we see, if we're talking radios, a Wi-Fi connection. So I think that's just where the state of that industry is, and kind of the need that fills. We don't typically see a lot of Bluetooth devices in the analyzer space. I think we're starting to see more and more Bluetooth devices as we talk about wearables and that technology, to where you're able to measure certain aspects about your body and communicate that over Bluetooth. And so those are really the two front runners that I've seen. Dan, I don't know if you want to add anything else to that.
No, I agree with you. I think recent history, I've seen less on the Bluetooth front. There's been a little bit of an uptick on requests recently. They tend to have harder use cases to implement in there. And then other ones we have seen in the past has been like Wi-Fi or the Cat6, like we're talking about. But a little bit of a mix for the most part. Yeah, the other question I want to talk about too real quick is going back to the FCC. I know one of the questions we got up front was pre-certification testing. Why do I have to go through that if I have a pre-certified chip? The pre-certified module has already gone through. It's already gone through the intentional emissions. So again, they've already done the upfront work on that big part of it. It's an intentional emitter. They've already gone all through that. The next thing you have to do is do the unintentional, because again, you're taking these chips and putting them into a unique implementation. You're changing the design slightly, so you do need to go through for that part of the vet. That's why it's shorter, because it's typically a shorter part of the test. You're only looking, if you can get a good schedule date, you're looking at about 1 to 2 weeks to get it knocked out. So again, pre-certified, you do need to finish up. I believe it's FCC Part 15, Subpart B, off the top of my head. But you still need to go through that portion of the test. Evan, I can answer your question on that too. So it's a mix. When you're doing like an ICT, FCT, and a final test, you're asking who typically designs those. It depends on what you have internally. In my experience, you usually outsource to like a contract manufacturer who actually does that more often. They make an ICT, they make the bed and nails more often. It also depends on the quality you need. I've seen people make ICTs that are pretty like cheap and low budget and make them out of 3D printed parts, but they're not going to last that long. They're going to crack after a while. If you're going for like steel tools and stuff like that, you may want to go with some other vendor that has experience with it. The way you do them traditionally is usually with your specifications. So for an ICT, it's based off of the Gerber files. Everything comes back from your actual layout design. There's also the opportunity there too that you can send over specs. Inside a spec, you can call out tolerances that actually meet and don't meet your requirements. So I would say it's a little bit of a mix. I would say the design team is responsible for producing some form of a spec, right? So like this is what the critical components are and they have to be within this range. And then the actual manufacturer of the tool can take the Gerber on those notes and actually build out the ICT. Typically the person that makes the ICT for you will actually do the software that runs the ICT. The same can be said about FCTs. That could be done internally if you have the resources, or you can outsource it to somebody. Again, you can go through using specifications to try to drive the need and like who actually does what. Same for final tests in that case too. And then as far as deciding what's being tested at each one of the stages, I would say that's on the design team and your manufacturing team. So if manufacturing is inside your business, it's kind of the design team, manufacturing working together to try to find the big outliers. If you're outside manufacturer, and your design team sends over control plans to them, which should be reflective to the test that you've been running. So you want to try to find your high-risk parts when you're manufacturing.
So next question is from Clara. So barring other usage limitations, if security is your priority in risk management, what type of wireless communication is the best choice? So I think you're asking if your only requirement is that you need to communicate wirelessly, what's the most secure medium? So whether that's Bluetooth or Wi-Fi or LoRa. From my understanding, and we need to do, I think, a little bit more research into this. So that all protocols have the ability for security to be in place with keys. The communication, I mean, naturally over wireless communication, you're going to have inherent risks. But if you put in place the proper certificates, then on both the device side as well as on the server side, then you can guarantee to some level that you are computationally secure, which is all that security can really go for is computational security. Given enough time and enough compute power, you can decrypt messages that are in transit, whether that's over HTTPS or if it's transmitted wirelessly over Bluetooth. So my recommendation there is to make sure that you select the radio that's the best for the use case. If it's going to be near field, probably Bluetooth. If it's going to be a little bit longer range and prevalent within the average home in a lot of countries, it'll be Wi-Fi. And if you need it to be a little bit more broad, then we're looking at something like LoRa. But once that protocol is in place, making sure that you have the proper certificates on both ends and that you're using proper protocols. So for instance, don't send network traffic over HTTP and expect somebody sitting at a Starbucks to not have somebody snooping in on their internet traffic. So I think that you need to apply security at all parts of the stack, and each radio has their own security practices in place that should cover you from a security standpoint. So I think if that's it for questions and answers, we can call this a wrap. We're going to be making the recording available, and so you should see a link to that coming out here soon. And again, thank you for joining. And if you have any additional questions, please follow up with us either via email or schedule time for virtual coffee. Dan and I can make ourselves available and make sure that we answer those questions and have those conversations.
Excellent. Thanks, everybody. Appreciate the time.